Here is a problem every automation engineer hits eventually. You are writing tests for a feature that makes an API call. Maybe it calls a payment processor, or a weather service, or your own backend. And you want to write a test that covers the case where that API returns an error. How do you trigger that? You cannot call the real API and ask it to fail on command. You could set up a fake server. That works but takes time. You could skip the test. That is technically not testing. Or you can mock the API. Replace it with a controlled stand-in. That returns exactly what you tell it to, every time, in milliseconds. Mocking is not cheating. It is one of the most important skills in test automation. It lets you test code in isolation, without external dependencies. That means your tests run offline. They run in CI without needing API keys. They run fast, because there is no network call. And they run deterministically, because you control every response. In this episode we are covering Python's built-in mock library, the pytest-mock plugin that makes it even cleaner to use, and the practical patterns you will use in real projects. We will look at how to mock an HTTP client, how to mock a database call, and how to verify that your code called the mock with the right arguments. This is one of those topics that feels confusing until it clicks. And then you wonder how you ever wrote tests without it. Let us make it click. Let us start with the concept before the code. When you write a unit test or an integration test, you are testing one thing: the behavior of the code under test. But that code might depend on other things: external services, database layers, file systems. Those dependencies have their own behavior, their own failure modes, their own costs. If you let them into your test is no longer testing just one thing. It is testing your code and the API and the network and whatever else gets involved. A mock replaces one of those dependencies with a fake object you control. The fake has the same interface as the real thing, so your code under test does not know the difference. But you decide what the fake returns. There are a few related terms you will hear: mocks, stubs, and spies. A stub returns a fixed value. You just want the call to return something so your code can continue. A mock is more powerful. It records calls. You can assert that it was called. How many times, with what arguments? A spy wraps the real implementation but still records calls. Python's unittest.mock module gives you all of these through a single class called MagicMock. A MagicMock is an object that accepts any method call, any attribute access, and returns another MagicMock. You can configure it to return specific values, raise specific exceptions, or behave differently on each call. It is incredibly flexible once you understand it. Python's built-in mock library lives in unittest.mock. The two things you will use most are the mock class and the patch function. Mock, or MagicMock, creates a fake object. Patch replaces a real object in your code with a mock for the duration of a test. Here is why patch matters. You cannot just pass a mock to your function. If your function creates its own dependencies internally. If your function does something like import requests, response equals requests.get. You cannot intercept that call by passing in a fake requests object. You have to patch it at the location where the code looks it up. That is the key insight. You patch the name as it is seen by the code under test, not where it is originally defined. If your module is called API client and it imports requests at the top, you patch API client.requests, not just requests. The patch decorator temporarily replaces that name for the duration of the test. When the test ends, the original is restored. pytest-mock is a plugin that wraps this in a cleaner interface. It gives you a mocker fixture. You call mocker.patch with the target string, and it handles all the setup and teardown automatically. No context managers. No decorators stacking up. Just mocker.patch and you are done. Both approaches work. pytest-mock is generally cleaner for Pytest projects. Let us walk through a real example with code on screen. Say you have a function called getStockPrice. It takes a ticker symbol, calls an external API with requests.get, parses the JSON response, and returns the price as a float. You want to test two things: The happy path, API returns data, you get the price. The error path, API returns an error, your function handles it gracefully. For the happy path test, you use mocker.patch to replace requests.get. You set its return value to a mock response object with a .json method. That returns your fake price data. Then you call getStockPrice with a ticker and assert the result matches your expected value. No network call happened. No API key was needed. Test runs in milliseconds. For the error path, you tell the mock to raise a requests.exceptions.timeout. Then you assert that your function either raises an appropriate exception or returns a sensible default, depending on how it is designed. You can also use mocker.patch to verify behavior. After your test runs, you can assert that requests.get was called exactly once, with the correct URL, with the correct headers. This is how you confirm your code is making the right calls, not just returning the right result. That distinction matters. A function might return the right answer by accident. Verifying the call chain ensures the code is actually doing what you think it is doing. Now that you know how to mock, here is the harder question: when should you? Mocking is powerful, but it has a cost. When you mock something, you are testing your code against a fake version of a dependency. If the real dependency changes its interface and your mock does not, your tests keep passing even though production is broken. This is called a false positive. Tests green, users angry. So here are the guidelines that experienced engineers use. Mock external services you do not own. Payment APIs, email providers, analytics platforms. You have no control over these. They change, they go down, they cost money. Mocking them is the right call. Mock the database in unit tests but not in integration tests. Unit tests should be fast and isolated. Mock the data layer. But you also need integration tests that hit a real database to catch SQL errors, constraint violations, migration issues. Do not mock things just because they are slow. If something is slow, fix the performance or use a test database, not a mock. A mock that hides a slow query is hiding a production problem. And be careful about mocking your own code. If you are mocking a function you wrote, consider whether that function should be extracted into a dependency that can be injected instead. Mocks work best at the boundaries of your system, the places where your code talks to the outside world. Inside your own code, prefer real implementations. Let us recap what we covered in this episode. Mocking lets you replace external dependencies with controlled fakes, so your tests run without network calls, databases, or third-party services. Python's unittest.mock and the pytest-mock plugin give you all the tools you need. The patch function is how you replace a real object at the location your code looks it up. MagicMock records calls so you can verify not just outputs but the exact behavior of your code. The key rule: mock at your system boundaries. External APIs, services you do not own. And external infrastructure. Keep real implementations inside your own code. If you follow that rule, your mocks stay accurate and your tests stay meaningful. Next episode we are covering parallel testing with pytest. If your test suite takes more than a few minutes to run, this is the episode for you. We will show you how to split your suite across multiple CPU cores, what makes a test suite safe to parallelize, and the common pitfalls that will burn you if you jump in without understanding them first. The goal is a test suite that runs so fast you actually run it. Not once a day in CI, but every time you make a change. Subscribe to QA Career Lab to catch it. New episodes every day. See you tomorrow.